So guys, welcome to Solutions to Academy once again. When we are about our motto for confusion to clarity and from test to testimony. Today we are going to be looking at what aromaticity. During the live class we did earlier, we've discussed about the history of aromatic compound and others. So now let's take for what aromaticity. Something you need to know about what aromaticity. Now the first thing you need to know is that what not all what cyclic compound, not all cyclic compound are what are aromatic. Yes, not all cyclic compound are what are aromatic. Before the classification of aromaticity, we have what we have three. So we have the aromatic compound, the anti-aromatic compound, and the non-aromatic compound. So by this class, you are going to know about the three classification. But before that, let's just jot down the definition of aromaticity. So aromaticity, it is the property of what conjugated cycloalkene. The property of what conjugated cycloalkene, which enhances the stability of molecule, due to the delocalization of electron present, in the what pi orbit, pi orbit in the pi orbit. Okay, paragraph. It results from particular bonding arrangement that causes certain pi bond within a molecule to be what strongly held. It results from particular bonding arrangement that causes certain pi electron within a molecule to be what strongly held. So dem ask you what causes stability what enhances the stability of benzene is what the localization of what pi electron. So now let's look at the word classification. The classification. As I said earlier, there are three classification. We have what the word aromatic compound, we have the word anti-aromatic compound, the anti-aromatic compound, and we also have the non-aromatic compound. So we also have the word the non-aromatic compound. Now let's take for the conditions for what aromatic compound. Condition for what aromatic compound to occur. Condition of aromatic compound. So how do we know that this particular compound is an aromatic compound? First thing is that what it must be what it must be cyclic. We all know that it must be what cyclic. Second one is what it must be conjugated. We know that conjugated in a plain way means what it must have what two bonds, presence of two bonds. It must be what conjugated. Third one is that it must, let's put it in this way, that what the compound must have 4n plus 2 pi electrons. So they must have what 4n plus 2 pi electron, and also it must be what? It must be planar. That is, it must be what? sp2 hybridized. Just like your alkane. It must be planar. sp2 hybridized. So let's take a common aromatic compound, which is what? Your benzene. So your benzene is in this form. So your benzene is in this form. The benzene is in this form. So we have double bond right here. 1, 2, 3. So now, let's check the what? The it must be. So let's check if it matches the rule. We said it must be cyclic compound like this. This is a cyclic compound. You know that the minimum cyclic compound you can have result must have what? At least 3 carbon, which should be in form of a what? A triangle. So this is also a cyclic compound. It meets up with what? With 1. It must be conjugated. It must be what? All carbon must be what? Must be enclosed with what? Must be enclosed with what? Double bond, abi? So we have a carbon right here. 1, 2, 3, 4, 5, 6. This carbon has a double bond. This one 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 also has a double bond, and this one also has a what? Double bond. Since they all has a double bond, it is also what? Conjugated. The compound must have 4n plus 2 pi electron. Do you remember the last time when we are talking about what? When we are talking about what? Single bond, double bond, and triple bond. We said what? Your single bond will only have 1 sigma. Your double bond will have what? 1 sigma, 1 pi, and your triple bond will have what? 1 sigma, 2 pi. Now you are having a what? Double bond. Immediately you are having what? 1 sigma, 1 pi. So example of this, 4n plus 2 pi. So that is this one. That is when your what? If assuming n is 0, are you getting me? If n is 0, 4 times 0 is 0. 0 plus 2, 2. We have 2 pi. N is 1. 4 times 1, 4 plus 2. We can have 6 pi. 2. 4 times 2, 8 plus 2. We can have 10. 3. 3 times 4, 12 plus 2, 14. So addition of what? 6. Addition of what? 4. You can have 14. You can have what? 18 dot 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 etc. Are you getting me? Now let's check this. So I have what? 1 pi right here, 1 pi right here. This carbon has 1 pi. This carbon has what? 1 pi. This carbon has what? 1 pi. This carbon has 1 pi. This one also has what? 1 pi. This one also has what? 1 pi. The total pi right here is what? 1, 2, 3, 4, 5, 6, which is what? 6 pi. It meets up with the rule of what? The carbon must have what? 4n plus 2 pi. Are you getting me? So this is an example. This one, it meets up with this rule. And the third one that is what? It must be planar. You know that it must be what? sp2 hybridized. sp2 hybridized will only have what? Double what? Electron. Double bond. Are you getting me? You must have possess what? Double bond. That's about what? Aromatic compound. Now let's do for what? For anti-aromatic compound. For anti-aromatic compound, for anti-aromatic compound, for anti-aromatic compound. So you can also know that what? Your any compound that has 7 carbons and below are planar. Are you getting me? 7 what? Carbon and below are planar. But that one doesn't mean that above 7 everything is non-planar. It must be planar and non-planar. But constant one is what? That is 7 having 7, 6. It will be what? It will be in a what? In a planar form. So now, for condition for aromatic compound, yes, it must be cyclic. It must also be conjugated. But right here we are going by it must be what? 4n. No plus 2. It be what? 4n. They must have what? 4n pi electron. Are you getting me? 4n pi electron. So let's take an example of what? Of anti-aromatic compound. So a typical example of aro a typical example of anti-aromatic compound is this. Don't mind my drawing. We have something like this. So we have one, we have two, we have three, and we have four. Yeah, this compound. Now double bond or two. So we want to let's check if the condition of aromatic compound it means the condition of what aromatic compound. So now since we are having 4n pi electron for anti-aromatic compound, then this one too will change. Then this one will be starting from what? From what? If n is 0, then we are going to have is 0, comma 1, 1 times 4, 4, comma 2, 4 times 2, 8, comma 3, 12, 4, 16, and so on. So now let's check if this condition meets the it must be what? It must be cyclic. This compound is what? Cyclic. It means with condition number 1, it must be conjugated. It must have what? It must have what? A double bond surrounded by it. Abi? So it must be conjugated. That's a double bond surrounded by it. Okay. The compound must have 4n pi electron. Okay. Let's take it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay now. So for this compound now, we have 4n pi electron. So we are going to let's check if it meets with the condition. So this carbon has what? 1 pi, 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 and what? 1 pi. So we're having 2, 4, 6, 8. 8 pi in total. So this 8. So it meets up with this condition also. Are you getting me? So the difference between anti-aromatic and aromatic compound is that what? It is mostly that what? It mostly difference in this what? Number of what? Pi electron. That one being what? 4n plus 2 pi electron, and this one being what? 4n pi electron. So an assignment from your knowledge of what? Naming organic compounds. Name this compound. Name this what? Name this compound and submit it to my DM. So now don't forget to subscribe to the channel. We lead for students from confusion to clarity and from test to testimony. Have a good day, guys.